Pre-established harmony, just like what we're about to do with the slides.
That is great. Okay,
And
so
there's Robert Adams. Very nice.
We are live on YouTube. I will send the links and then we'll start the session, because if I'm moderating, I cannot. Okay, so here's the YouTube link for everyone. Right, I will just mute all the people I can apart from the speakers and then start. Okay. So welcome everyone to the second to last meeting for this semester at the seminar. Today we will have a panel on Leibniz, entitled Leibniz on Laws and Spiritual Causation. The format is going to be that Brian Pitts is going to give his presentation and then have a Q&A, and that will take about 45 minutes. Then we'll have a very short break, and then Andrew Chignell is going to give his presentation and have a Q&A for about 45 minutes. And at the end, if there is a time, we will have a joint Q&A with whatever questions pertain to both presentations or were left over from the previous Q&As. Okay, so without further ado, I will invite Brian Pitts to start his presentation. I will actually be sharing my screen for this purpose because Brian's share screen doesn't work. So let me try to do that. And hopefully, Brian, you can kind of tell me when to... Does everyone see this? Is this okay?
Okay, yes, good. Thank you very much for the opportunity to speak, and to all of you for coming. I know you have a choice. So I'll be talking about the mind-body problem, which of course goes back at least to the 17th century, and the question of conservation laws, which also goes back to the 17th century. But I'm going to be taking an unabashedly normative look at the history. So I'm interested, you might say, in what people said philosophically and what maybe they should have said in light of the physics of their day and also the physics of our day. I'm going to have a bit of pre-established harmony, I'm afraid, with the slides here, at least if all goes well. So next to the outline, please. Just page down or something to do. Yes, okay. So I'm going to talk about 17th and 18th centuries, and then look at the 18th, 19th, early 19th century, and then the 19th and 20th century, and then I will bring out some more contemporary physics and the difference that that makes, although I'll be tipping my hand from time to time as we go. Okay, so this discussion goes back to 1695, so that's over 320 years and maybe 35 or 40 minutes. Obviously, I can't say everything. Plus, there are sources in at least 4 languages. I can't say I've read them all, and I probably haven't made the maximum use out of those that I have read, but I think that I've got a reasonable approximation of the story. I'm also, I mentioned telling a normative story. So for some people that might be dangerous and transgressing anti-Whiggism. It's not that I'm quite in favor of Whiggism, but I would say, well, Hasak Cheng says it's okay. And I think historians of math also tend to be quite happy to tell normative stories about who knew what when. So and I might also point out, for those who are interested in philosophy of mind for contemporary consumption, that this conservation objection is also relevant to property dualists, at least if they're not epiphenomenalists. Now, quite a few property dualists have been epiphenomenalists. On the other hand, if it's kind of hard to see how, if given epiphenomenalism, why anybody bothers to talk about these things, because they can, these properties of redness or whatever can never have motivated anyone's body to do anything. Anyway, so it isn't just a historical issue. Also, thanks to my funders a few years back, my funder and to collaborators, all errors as usual are mine, and opinions as well. Okay, so in the 17th and 18th century, there was a discussion of, advance to next slide, please. Yeah, a little more. I should have a picture of Leibniz now. There we go. Good. Sorry, I was not having you advising you as I was advancing. So Leibniz often, including in the Theodicy, made an argument from conservation laws. So here's what he says in Theodicy. Two important truths have been discovered since Monsieur Descartes' day. The first is we might call the conservation of energy, or vis viva. The second discovery, basically the momentum is a vector. So as an aside, momentum conservation was from Wallace, Huygens, and Wren around 1680. So back to Leibniz. If this rule had been known to Monsieur Descartes, I believe that would have led direct to the hypothesis of pre-established harmony, whither these same rules have led me. So Leibniz has a very strong reading of these conservation laws. I mean, it wasn't entirely clear what you'd even do with inelastic collisions. So elastic collisions, like rubber balls, bounce off each other as hard as they came in, or at least approximately. But what if you have, say, snowballs that hit each other and stick? It doesn't look like the living force is conserved there. So that was kind of awkward. I guess Leibniz had a story for that, but it wasn't really gripping maybe for everyone at that stage. So advance, please. So now I'm going to be quoting Dan Garber. I haven't done this with him in the audience before, and I hope you still believe this. Anyway, so a while ago he said, there's reason to believe that Descartes may never have been committed to the position that his conservation law holds universally, and may have allowed for the possibility that animate bodies lie outside the scope of the laws that govern inanimate nature. So Descartes may not have believed in conservation law so strongly as Leibniz did. Now, Descartes did have a notion of conservation of speed, as we saw. Conservation motion is like volume times speed, but maybe it didn't apply in the context of souls. And another quotation, again from Garber, Descartes writes, all of the particular causes of the changes which happen to bodies are contained in this third law, at least insofar as they are corporeal. For we are not inquiring into whether or how human or angelic minds have the force to move bodies. So maybe Descartes doesn't think these conservation laws even should hold if there are souls acting on them. So if that's true, then Descartes would be an early proponent of what I'm going to call the conditionality response, namely that conservation holds as long as there's no non-physical force acting on the body. But if there is such a non-physical force, then conservation may simply fail. Okay, so that's Leibniz, that's Descartes. What about Newton? So the Newtonian tradition of forces could include mental forces, as even David Papineau points out while making an argument for physicalism. So Newton would not have been terribly moved by this sort of argument. And Clarke, I think, similarly would not have been. Clarke was, of course, Newton's stand in the Leibniz-Clarke debate. And he was a libertarian, and it seems really hard to see how libertarianism could be compatible with conservation laws. But here's Newton in a draft for the optics. So this didn't make the final cut, but it presumably is something that Newton at least believed, given that he put it in a draft of his book. Seeing, therefore, the variety of motion which we see in the world is always decreasing, in other words, he thinks vis viva isn't conserved, there is a necessity of conserving it and recruiting it by active principles, such as are the power of life and will by which animals move their bodies with great and lasting force. End quote. So Newton there seems to be a proponent of mental causation, even for animals, and this is probably the intuitive thing you think. So you offer your pet some kind of food, and maybe the pet gets all excited and starts chirping or barking or whatever whatever is appropriate for the animal it is. It kind of seems like there is mental causation, much like we have. So if you have mental force, well, surely Newton's third law of action and reaction should fail. And so there ought to be non-conservation of momentum. So I don't know that Newton explicitly says all this, but it seems like he should have said at least conservation laws would just fail in the context of mental causation. And of course, Newton would probably disagree with Leibniz anytime he could. That might be another reason. But it would help to have something more explicit and philosophical. So here is another remark from a draft for the optics. We find in ourselves a power of moving our bodies by our thoughts, but the laws of this power we do not know. And see the same power in other living creatures, but how this is done and by what laws we do not know. And by this instance and that of gravity, it appears that there are other laws of motion, unknown to us, than those which arise from vis inertiae, unknown to us, which is enough to justify and encourage our search after them. So what I conclude is Newton is a fairly vigorous proponent of mental causation, and hence would not have been at all impressed by Leibniz kind of argument, even waiving the fact that, I mean, even apart from the fact that Newton didn't believe in the conservation of energy, you could still have the same debate about the conservation of momentum. And I think Newton would have said that the conservation of momentum could just fail also. That seems like the thing for him to have said. Of course, Leibniz did have followers as well, in particular Wolff and some others. I'll mention Wolff and Bilfinger. So Leibniz talked quite a bit about this objection from conservation laws against mental causation, something like half a dozen times. So he must have really liked it. Wolff also preferred pre-established harmony, but interestingly, he didn't demonstrate it, which is significant because Wolff thought anything important should be demonstrated. And one of his reasons for preferring pre-established harmony over interactionism, or what was called physical influx in those days, is, not surprisingly, the conservation of forces. So the usual conservation objection that we're finding here. So here it is in Wolff, physical influx is contrary to the conservation of living force, and so on. So if the mind acts on the body and the body acts on the mind, then the total amount of motion changes or whatever. Something along those lines. Okay, so Wolff made that argument, so did Bilfinger, and evidently, if you want the best defense of pre-established harmony ever, the way or where to find it is in Bilfinger's De Harmonia. And the conservation of vis viva objection is indeed made there. So, as Eric Watkins says, Bilfinger rejects physical influx for many of the standard reasons. It seems to violate the law of the conservation of motion, and so on. So quite a bit of what I'm going to say about the 18th century German scene is, descriptively speaking, following Eric Watkins. I'm going to be throwing in my own little normative flavoring from time to time while that descriptive situation holds, however. So what about Martin Knudsen? It was described as a Wolffian, but also a proponent of physical influx. Well, when people remember Knudsen, at least if they aren't experts on the period, they probably remember him as the teacher of Kant. But Knudsen responded to this objection from conservation laws by just denying that the conservation holds. He notes, quoting Watkins now, that the law has been proved only for elastic bodies, not for inelastic bodies, much less for the mind and the body. Knudsen even provides a reason why this law should not hold for the mind. Since Leibniz derives the law of the conservation of motion from the law of inertia, and the law of inertia does not hold for the mind, there is no reason for the conservation law to hold for the mind. So I see in Knudsen here, again, an example of the conditionality response, which seems to have been the typical thing for those who are described as pietists to have said. And here's my little normative stamp. This was also the right thing to say. Given that Leibniz is dialectically on the offensive, he needs to make his case. And so an interactionist can simply assert interactionism and still be fine. The interactionist was not attempting any sort of proof. Okay, next, turning to Crucius. Next slide, please. Got it, good, thank you. This is again from Watkins. The third objection that Crucius considers is that physical influx would violate both the law of the conservation of motive forces and the law of the conservation of motion. Crucius's full reply is novel. He bites the bullet and rejects as impossible these particular laws of motion, noting that if they were true, the absurd result would follow that minds could not cause any motion, and as Reusch, and I've skipped Reusch, but anyway, as Reusch had noted earlier, that matter would not be able to fulfill the purpose for which God intended it, namely to be a means for free and rational beings. In other words, if you think about why God created the world and beings like us, it seems really, really implausible that Leibniz's conservation laws would hold, at least in relation to our minds. So this again is an example of the conditionality reply. So you might wonder why attend so much to 18th century Germany. Well, there are a lot of reasons. One of them is that analytic philosophy of mind recalls almost nothing between Leibniz's monadology and the 1910s on this point. It's kind of like nothing happened. Another reason is that no less a figure than E.J. Lowe, who had some incentive to know about this history, thought that the conditionality response was unexemplified in the 17th and 18th centuries. Well, as we've seen, it arguably had on its team Descartes, likely Newton, certainly Knudsen and Crucius, and I haven't said this yet, but likely Euler as well. So this is a really powerful team, particularly relative to a team that Lowe thought didn't exist. I might also say that the philosophy of mind that is deals with physics in a way that's really not very different from how it was in the 18th century. It's kind of maybe in the 1860s or so, basically what you'd find in a high school chemistry book. So the physics is not so obsolete in the 18th century either, compared to the more recent debate of the philosophy of mind. So that basically the 18th century German debate covered most of the issues pretty well. And I would point out the conditionality response is the right thing to say, given modern physics having to do with symmetries and conservation laws. I'll get to that, with the exception of general relativity. And I'm unfortunately not going to have time to talk about general relativity. It actually does make a difference. And you've probably not heard anything about that. And if you've heard anything about that, it may not have been the case. What's been said hasn't been right. So there are some new calculations one can do. Anyway, apart from general relativity, the conditionality response is what an interactionist ought to say, or maybe something about quantum mechanics. That's another possibility. Okay, next slide, please. So moving on to Leonard Euler. Euler was one of the greatest mathematicians ever, and I think is considered the most prolific. He worked on mechanics, fluids, optics, and acoustics. So despite the anachronistic term, we can safely call him a physicist as well. And the Euler-Lagrange equations are crucial in theoretical physics. And Euler actually basically invented continuum physics. He wrote down the first general equations for fluids, the Euler fluid equations, and he also invented the idea of local conservation laws. And this is a key distinction in terms of what conservation laws are like in serious physics compared to what one tends to hear in, say, high school chemistry. So local conservation means that conservation happens place by place. So it's actually like infinitely many conservation laws at any moment of time rather than just one. So it's a much stronger claim because energy and momentum are in particular places and travel at finite speeds. So for Euler, the conservation of living force just isn't generically true because there are inelastic collisions. You can throw two things together and they may stick. So that being the case, that wouldn't be the conservation of living force wouldn't be a worry regarding momentum causation. There's still the question of momentum conservation, but Euler, I think, should not have believed in momentum conservation either when the question of mental causation arises, because Euler was a staunch interactionist dualist and an opponent of pre-established harmony, as you can clearly see in his letters to a German princess. The year here is from an English translation. Excuse me. So Euler quite carefully instructed his German princess student that the soul acts on the brain and the pre-established harmony is false. So Euler was also a Christian apologist, and he in fact defended the Bible and the existence of evil spirits in his Rettung. There's an old French translation, and on the web there's a new English translation if you like that. So this was in the context of Berlin, Frederick the Great, and Voltaire. So this wasn't the fashionable thing to believe, but Euler believed it, and hey, he was smarter than everybody else, so he probably felt didn't feel too bad about that. Now, I confess, I don't know if Euler explicitly addressed Leibniz's objection, and I've raised the question with the Euler archive, and they don't seem to know that either. But I think we can tell what he should have said and what he most likely thought, because he knew all of the relevant physics, and he invented a bunch of it. So it's very hard to imagine that he just missed something in this context. And he was just too good of a physicist to think that interactionism and conservation were compatible, but he clearly was an interactionist. I'm neglecting gravity for the moment, which is an action at a distance theory at that stage, of course. So Euler evidently simply would have said, in the presence of mental causation, the conservation laws fail. So conservation is conditional. I don't see how he can have avoided thinking that, though I don't know if he explicitly said it. Okay, so that's the 18th century. So pre-established harmony was influential for a while, but it actually was defeated and interactionism regained the upper hand. That's an interesting story. I don't know that anyone has really told it. I would be fascinated to learn if so. But moving up to the late 18th and early 19th century, this will be a bit quick. Well, I'll say a bit about Kant. So the young Kant was an interactionist. Already pre-critically, he denied a localized seat of the soul. So he might be reluctant to say the soul acts, in a particular part of the brain, for example, as Euler would have said. The critical Kant, of course, distinguished between the noumenal and phenomenal realms, and hence would not be looking for a seat of the soul as Semmering was looking for. So to the degree that one follows the critical Kant, one will tend to think that questions about how the soul and body interact would be malformed or something along those lines. Instead, we should separate philosophy, which talks about the soul, from anatomy, which talks about the brain. Moving on a bit to the later 18th and early 19th centuries. So interactionism recovered. Joseph Priestley wasn't altogether happy about that, but that's what happened. And the conservation of vis viva, well, just had too many exceptions. I mean, there were just, there were inelastic collisions, and so it looks like conservation of vis viva was false. And one gets the caloric theory of heat. So if heat is its own kind of conserved fluid, then it's clear that vis viva could not have been a conserved thing because, hey, we now have a conservation law that includes them both. So clearly, conservation of vis viva was largely discarded. And the mechanical philosophy of Descartes and so on seemed to simply fail to do justice to biology. And so one gets vitalism, romanticism, nature philosophie, and that sort of thing. Matter is active, and it's not so much souls that are different as just life is different. So souls might be less distinct from matter because matter might be alive, or at least some of it might be. So that's kind of a shift in what some people are thinking. If you're Kantian, then you'd have critical Kantian scruples about even having this discussion. Another important trend, I think, is what we might call the progress of the spirit of rationalism, to borrow Lecky's phrase. Basically, there is just, at all times, with rare reversals, a shrinking willingness to appeal to the causal influence of spirits. And this was not necessarily evidence-based. Much of it you might just call anti-enthusiasm, enthusiasm being the belief that one is divinely inspired, and a lot of people, sort of the wild edge of religious practice, had such beliefs and made prophecies that didn't really work or acted crazy or whatever. So this was something that many Enlightenment people reacted against. And of course, there's also progress in neuroscience. People are coming to understand the brain better, and the more carefully we look, if we don't find what seems to be the soul acting, well, the less probable it is that there is a soul acting on the brain. Okay, next section. In the 19th century, the conservation of vis viva, or energy, winds up getting revived. So Count Rumford bores some cannons and makes as much heat as he wants. Sir Humphrey Davy melted ice with friction. Caloric fluid went away in favor of a kinetic theory of heat. And with Joule, we have a mechanical equivalent of it. So you could figure out, just how the conversion worked. And so one could then have the conservation of energy, which got the impressive title of the first law of thermodynamics. Now, I am at this point omitting what you might call high theoretical physics, stuff like the least action principle, the symmetry conservation link, and continuum physics or local field theory, partly because some of those things were mostly the province of analytical mechanics, which was a specialized topic worked on by mathematicians. Theoretical physics hadn't been invented as a discipline until Carl Neumann in the late 19th century. And physicists wouldn't tend to know this sort of, or do this sort of mathematics. And it was not believed that the principle of least action was very widely applicable anyway. So this was all rather specialized and mathematical. That changed by, say, the 1910s. And so it'll become increasingly relevant as we go. So not many people would have thought that the principle of least action and whatever it said about symmetries and conservation laws was applicable or relevant to the philosophy of mind, if they even knew about it. Okay, so skipping ahead a bit to the 1860s to 80s. So Helmholtz is important in discovering the conservation of energy, among other people. Helmholtz is also important in reviving the Leibnizian objection to interactionist dualism. So with the conservation of energy revived, at least some people like Helmholtz, Dubois-Reymond, and Clifford, W.K. Clifford, thought it reasonable to revive this objection. And of course, all of these people were working on some sort of physicalist research program or something along those lines, which is fine. And so they're making an argument for the reducibility of physiology to physics. And of course, insofar as Helmholtz and Dubois-Reymond were doctors, that seems perfectly sensible. Clifford, as a mathematician, doesn't seem like a particularly relevant expert. Anyway, one thing to keep in mind is interactionism was always incompatible with momentum conservation. And momentum conservation had been undisputed as a physical claim from the late 17th century. So any informed person who, physically informed person who is an interactionist, like say Newton or Euler, should at least have thought momentum conservation is just false when minds act on bodies. And therefore, if you introduce a new conservation law or revive the conservation of vis viva, maybe with a new name, it really doesn't matter at all, logically speaking, because if the soul can violate the conservation of momentum, there's no reason it shouldn't be able to violate the conservation of energy as well. But sociologically, that is certainly not what people thought. So I've tried to figure out, well, what is it that was novel about the conservation of energy that motivated the revival of this objection? So, I mean, there can't be a good reason, but one, there may be reasons of varying quality. So maybe they just didn't really grasp the physics and the implications of the conservation of momentum, which had never gone away. Or maybe just the publicity of energy conservation made a lot of people talk about the issue. Maybe neuroscientific progress is playing a role. Clearly, Helmholtz and Dubois-Reymond are involved in that. Maybe it's the onward zeitgeist against spirit to matter influence. Maybe it's, at least in the Anglophone world, maybe it's 19th century Baconian inductivist zeal for finding laws, often with gratuitous capitalization. So sociologically speaking, here's what Frank Turner, Victorian historian or historian of Victorian period, had to say. The contemporary significance of this law, that is the conservation of energy, was immense and probably more destructive to a supernatural interpretation of nature than was evolution by natural selection. So who knew? Leibniz in the 1860s was more damaging than Darwin to belief in souls and angels and God as playing a role in the world, at least according to Frank Turner, and he ought to know. So again, keeping in mind that that momentum conservation was always incompatible with interactionism, and a lot of people just said, too bad for momentum conservation in the presence of souls, or at least were committed to that view. It's kind of hard to see what good reason appeared in the 19th century, and so I just don't think there was one. My impression is the conservation of argument flourished in the 19th century, largely because, well, interactionists or friends of mental causation retreated. They had basically made an unforced retreat. So to give a military analogy, suppose you see an army retreating from a castle to a trench. Well, you'll probably think that the castle is indefensible, because otherwise, why would you retreat? If you were told the army retreated voluntarily, you'd probably find that very surprising. So what did people say if they were sympathetic to stronger versions of mental causation? Well, one response that you can find, although some of this is admittedly private, like in Maxwell's work, is basically a version of the conditionality response. So Maxwell, Stewart, Cournot, and Saint-Venant all talk about something along the lines of the delicate construction of life. So suppose you fire a gun or sail a ship or control a train. If you fire a gun, you don't have to use your soul to hurl the bullet at 600 miles an hour or whatever it's going. Or if you control a train, your soul does not push the train. Rather, your soul does something very small on an interactionist view, which directs the release of a lot of physically stored energy. In other words, the soul doesn't need to do very much. And some of these people would say maybe it can do infinitely little. So basically, conservation isn't quite true, but it's so close that you'll probably never notice, which is a way of saying that the conservation, if you change the emphasis, it's a way of saying that conservation doesn't hold in the presence of momentum in the presence of mental causation. And hence this would be a version of the conditionality response, while taking a form that would be consistent with our evidence, because what the mind does is so slight, if you will. So that would be basically the same kind of story that I was already calling attention to in the 18th century. On the other hand, there was another view that some people entertained, including some of the same ones, if they were interested in vitalism or dualism. And that would be to say, maybe conservation holds, but through some sort of clever idea, there's still room for the mind to act. For example, maybe differential equations in certain cases lack unique solutions, according to Boussinesq, who is mostly remembered now, I think, for working on fluids. Now, this works only in very special circumstances, but Boussinesq thought that these would occur in life. And Maxwell liked this idea better than small bits of non-conservation as well, because he said he didn't like looseness in the laws. So I think there may be some similarity from the 20th century appeals to quantum indeterminism that one sometimes sees. And in those contexts, one sometimes hears claims about a weakening of the conservation laws due to, say, energy time uncertainty relation, and the position momentum uncertainty relation, and so on. I realize that that those claims are controversial. Anyway, this was a direction that people who wanted to affirm mental causation in some reasonably strong sense tended to go. So rather than just digging in favor of the conditionality response, they tried to concede that conservation was true, and yet somehow there was still some sort of crack through which the mind could act. And that, it seems to me, was probably strategically not a good idea, because if you prefer the second option, then you're more or less de facto conceding strict conservation, while holding a view that may actually not work. So this seems like an unforced surrender of territory that one actually might need if you want to have an interactionist view. So maybe it's best to affirm the disjunction and keep both options. So it's interesting to compare to Sir John Eccles, neuroscientist, interactionist, dualist, and Nobel laureate, who into his 80s felt stymied by energy conservation until Henry Margenau showed how to retain energy conservation along through some sort of quantum move. So what's striking to me is here is the world's leading brain savvy dualist whose theorizing was constricted quite unnecessarily by an excessively strict attachment to the conservation laws. He only seemed to have the second of those two options in mind, and didn't have the awareness that one could take the first. So this seems to me to have been an interesting wasted opportunity for testable neuroscientific hypotheses. So now I want to go into some parts of physics that are rarely applied. I'm going to stop short of talking about general relativity, and so this will not be the last word. That one could talk a lot about general relativity. But one thing to point out is, and we saw a bit of this earlier with Euler, is conservation laws are local. In other words, energy is in particular places. So a conservation law does not, in serious physics, take the form energy equals constant or the rate of change of energy equals zero, but rather you have to pay attention to where the energy or the momentum, as the case may be, is and how it moves around at finite speeds. Nothing teleports, just disappears, or just pops into existence. And from the 1910 onward, at least formally, that's also true for gravity, which had been the main holdout. So already Euler had the idea of local conservation laws. So the idea is for each little volume, the energy in it changes only insofar as energy flows through the boundaries. And you can write this mathematically. It takes, unfortunately, it takes multivariable differential calculus to express this mathematically. So it looks like this. So if someone really talks about the total energy of the universe staying the same, well, that is logically, well, it's almost much weaker than this local conservation law, because this local conservation law should actually be quantified over. So you should quantify over all places and all time. So this is, if you like, some sort of continuous infinity of conservation laws, which has the benefit, has the benefit that you could have it true everywhere except, say, in my head. And most of the world wouldn't notice. If you're designing nuclear reactors, what's going on in my head is not going to make a difference. If you're studying the sun or designing refrigerators or whatever, you're just not going to notice. So it's not the case that the whole world collapses, although Mario Bunda claimed that the whole world would collapse if energy conservation were false. Okay, another part of theoretical physics that is rarely attended to in these debates that is quite relevant is the principle of least action. So this was mostly in rational mechanics by mathematicians like Lagrange 200 years ago, and it was not widely accepted as generally applicable before, say, the 1910s. In the 1910s, the principle of least action basically becomes the basis for what we might now call classical physics. More or less the same time they realized it wasn't true, they realized that it was generally applicable as a warm-up exercise. So that's kind of ironic. And this would include general relativity, by the way. It doesn't include quantum mechanics except as a warm-up exercise, but it's a stepping stone to quantum field theory. And within the principle of least action, you can see how symmetries and conservation laws are related. So symmetries are basically uniformities of nature. And within analytical mechanics, these ideas existed already in the first half of the 19th century. So Lagrange understood that the sameness of laws over time implies energy conservation. If you don't have T in your kinetic and potential energy, then you get the conservation of force V, Lagrange says. Yeah, if you could advance a little bit, please. There we go, that quotation there. Likewise, if the Lagrangian, so the Lagrangian function is basically kinetic energy minus potential energy, and it's the function that you add up over time in order to, to get the action that is minimized in the principle of least action. So if the Lagrangian density doesn't depend explicitly on location, then momentum is conserved, as Hamilton and Jacobi pointed out. Or you could simply think on Newtonian grounds. You would normally expect some kind of action-reaction law. But if the soul acts on the body, it seems really absurd to suggest that the body acts on the soul in an equal and opposite way. So that would, the third law would just fail, presumably. And hence you would expect momentum non-conservation due to the mental causation going on in the brain. So another feature of contemporary physics that tends not to appear in these debates is the converse of these symmetry implies conservation results. This converse was something that Emmy Noether called attention to, and in our day, Catherine Brading and Yvette Kozma-Schwarzbach have emphasized it. So by contraposition, you could say that non-symmetry implies non-conservation. Now, if I have a soul and it acts on my brain, it does so on Earth during my life, not on Mars 100 years ago. So in other words, it doesn't treat all times alike or all places alike. It violates the uniformity of nature, and hence conservation laws will fail in my brain during my life, if I have a soul that acts on my brain, that is. So that is Pache mini-dualist efforts to respect conservation. But it's not going to get in the way of engineers or astrophysicists. So at this point, we can see how it is that the Leibnizian objection is circular. So physicalist philosophers of mind like Leibniz and Wolff tend to think that physics gives us categorical energy conservation. But Aristotle pointed out to us premises should be better known than and prior to their conclusions if you're making a scientific demonstration. But in light of Noether's theorem, first theorem and its converse, symmetries in conservation laws are equally well known and neither is prior to the other. So yes, the claim that souls act on bodies clearly violates symmetries, and therefore conservation of energy momentum fails in brains given interactionism. But what isn't clear is why we should apply modus tollens rather than modus ponens. The interactionist ought to say, yeah, so what? How hard have we looked? Have we looked in the soul hard enough, and then the brain hard enough to see that there's no soul acting there? And of course, maybe we have. That would be an empirical neuroscientific claim, which would be a totally different argument from Leibniz's. So that, I think, is where the real debate in this context should be or should have been. The theoretical physics argument doesn't really work at all. Okay, so something like this was pointed out by Jeremy Butterfield in the late 90s, although the message didn't really get out. This argument, he said, noticing Dennett as a recent proponent, this argument from conservation laws against interactionism is flawed for two reasons. The first reason is obvious. Who knows how small or in some other way hard to measure these energy gains or losses in brains might be? Agreed, this reason is weak. Clearly, the onus is on the interactionist to argue that they could be small, and indeed are likely to be small. Skip a bit. In short, physicalists need to be wary of bad reasons to think physicalism is true, arising from naivete about physics. So one needs to distinguish between respecting what's in your high school chemistry book and respecting what is in graduate level physics books, because they're just quite different, to recall a warning that James Ladyman gave us. In particular, we need to pay attention to Noether's first theorem and its converse. So to conclude, the objection from Leibniz to Dennett or Bunhe or Paul Churchland or many others, I could have cited a lot of modern authors, is tendentious or circular. And it was addressed well in the 1720s to 1760s in Germany, as Eric Watkins described, though I added my own normative touch. And I think this conditionality response is still appropriate given centuries more physics, at least prior to general relativity. And you would have other options maybe with quantum mechanics as well, because quantum mechanics, if anything, makes interactionism easier. On the other hand, general relativity makes interactionism harder. And as I mentioned, I don't really have time to go into this. This is not something you will have heard from anyone else, I don't think. But general relativity does make interactionism harder, but not insuperably hard, at least not for the sorts of people who are likely to be most likely to be interactionists, namely theists. So I think what's really crucial is actually not the physics. The physics doesn't settle the issue. One has to take a look at the brain. But that is, of course, a completely different argument from the one that Leibniz and his many followers have made. Thank you.
Thank you, Brian. All right, so let's take questions. Please drop a line in the chat or put your hand up if you have a question. Daria?
Hi, thank you for your presentation. I have just a question for understanding. You was saying that soul acting on body violates symmetry requested by Noether's theorem. Could you explain this, please?
Yeah, so if you write a description of the mental causation So I mentioned, my soul acts on my brain, let's say, or maybe it acts on my body, or who knows, maybe I can levitate objects across the room, but I can't. But anyway, if there are souls that act on bodies, they don't do the same thing everywhere. They do particular things in particular places at particular times. And so when you write that down, the physics will explicitly depend on the time and place because of the spiritual force, if you will. So the soul's causal influence, because it varies with time and place, introduces explicit dependence on time and place into the physical laws, and therefore the symmetries are false.
I'm sorry, but if you have a motor in any other mechanical device, and motor also is acting in a certain time and a certain place, what is the difference between driver in technical mechanical device and soul and body?
Well, the difference is if you're talking about purely physical systems, then they will be taken into account as having energy and momentum and acting upon each other. Whereas the soul will just be this, it's maybe not quite an unmoved mover, but it's something like an unmoved mover. And from a more physical perspective, it's like an external potential. It's something. It's an influence that is just applied, but it does not itself have physical equations of motion. I mean, if the soul had physical equations of motion that were given by Euler-Lagrange equations, then the symmetries would hold. But of course, then it wouldn't be a soul anymore; it'd be a body. So it's because it influences the physical equations of motion. It appears mathematically in the equations of motion, but does not itself have equations of motion. That's why the symmetries wind up false.
Okay, thank you.
I hope that helps. If I were to show you some mathematics, then that might make it clearer or might not, as the case may be.
Thank you. Des?
Thank you, Brian. Can you hear me, Brian?
Yes.
Yeah, thanks. Very interesting. Do you see any interesting relationship between Newton's empiricism about the third law compared to, say, the view of Leibniz and Kant that there is a rational proof of the third law, and your classification of Newton as a conditional theorist in this sense? Obviously, he says in the Principia that he went and he tested the third law and he found that it was true, and he did quarks in water and he did pendula and what have you. So he's treating it as, it's not a given that it's going to come out correct, whereas Kant just presents it as basically, well, he's got this Archimedean argument. He says, take any two bodies moving towards each other, whatever their masses are, whatever their velocities are, add their velocities together, and then divide the velocities inversely to their masses, and then you get equal momenta in that frame of reference, and then you're supposed to just know what's going to happen when they collide, right? Just by the kind of Archimedean argument, there's no reason why one thing should happen rather than another thing, and therefore resolve back into your previous frame of reference, and you get that the third law is true as a rational principle. Newton is not attracted to that, obviously, otherwise he wouldn't be testing this. Is there any connection? Have you seen any connection between that and his views about mind-body action?
That's a very good question. I confess I know less about Newton's empiricism about the third law than I should, but I should read some more about that. I mean, maybe the fact that Newton is having to invent or discover the third law and doesn't have some really famous person named Newton that he can depend upon, plays a role here also. I think that's a very good question, and I don't think I have a very good answer. But I'm glad you asked, and I'll have to keep thinking about that. So thank you.
Thank you, Terry Bristol.
Thank you. So it seems to me there's a slightly different line of development on this. It seems to me the important concept that Leibniz introduces is the concept of an action. And for me, I find it easier to understand it through Maupertuis. And the idea is that MV and MV squared are two, I call them complementary, two complementary components of any real change. So change is action, and it's the action that's conserved. It's not, when you talk about, when you switch over and start talking about conservation of energy, it's a different line of thinking. So I think from Leibniz to, and I think Maupertuis for me is clearer, but his idea of the orbit, you know, there's the MV version and the gravitational thing, and that's, so he sees everything in reality as made up of these two complementary components. That the place I like where it goes is to Lazare-Carnot, where he talks about, you know, he actually sees the participant, and in the last part of his fundamental principles of equilibrium of motion, he actually talks about energy and power and work in a different line that I think is something that Leibniz would be comfortable with, but I think the line that went through, you know, Helmholtz and Joule and all that is a completely different line. We're talking about energy in a very different sense. The other thing last thing I mentioned, it's interesting that Max Planck was, as I say, obsessed with initially Maupertuis, and then he goes, oh, it isn't Maupertuis, it's actually Leibniz who did this stuff, because the concept of action in quantum theory and the concept of action that's introduced by Leibniz and then developed and by Maupertuis is the same thing. It has to do with this energy time thing. Anyway, I don't know if you've tracked that line of thinking at all.
Thank you. So, I mean, I've read a bit about the controversy over the true measure of force from the 1720s and so on. And I mean, I guess I'm pretty satisfied that the answer is, well, they're both part of what we should mean, and it's useful to have different words for the two, and we don't have to have a sort of Newtonian or Leibnizian partisanship. Mathematically speaking, by now we understand something that was, I think, not at all clear in the 1720s, but was clear 100 or 150 years later, namely that these conserved quantities are both generally true conservation laws related to symmetries, but they're related to different symmetries, one to time and the other to space. And I don't know, I mean, maybe you could just kind of sit in your chair and think about how that would be, but for me, well, it follows from the mathematics. And space and time are alike in many respects and unlike in other respects. And well, of course, once you're talking about local conservation laws, then the notion of conservation no longer prefers time either, because you wind up with rates of change with respect to time and with respect to place. So, yeah, I think the historical origins of these ideas are fascinating and important. I think, you know, one sees a new level of clarity in the 19th century with people like Lagrange and Hamilton, and you know, that's kind of, you know, those are, if not the earliest, at least some of the earliest places that I know of where one will see the symmetry conservation law link in a way that you know, one would now want to make that connection.
Thank you. So we have 3 more questions on the list, but I don't think we'll have time for all of them. We're already at 55 minutes, but I think we'll just suspend the break. Vincenzo?
Yeah, so I will be very quick. It is just a historical clarification question. That is to say, the principle of least action was considered at the time, as Leibniz probably considered it, another formulation of the conservation of energy. And in this sense, were the actors in the 18th century, like Maupertuis and the others, who often were Newtonians, convinced by the principle of least action about the conservation of energy, and do they take this as an argument against interactionism or physical influx?
Good question. So I don't know I don't recall whether Maupertuis has anything to say about this, and maybe I never did know on the matter. I've been attempting to learn about whomever I could learn about in the 18th century. If Maupertuis talks about it, I would be glad to be informed. I think that there isn't any difficulty in other than maybe partisanship and or habit or something like that, in having a notion of conservation of energy in a broadly Newtonian framework. I mean, nowadays, Newton's not the latest thing, but Newton, physicists will think, yeah, Newton, his laws, that's all great stuff. And the conservation of energy is just happily integrated along with the conservation of momentum. So I think there was a lot of unnecessary partisanship and going back to Newton's and Leibniz's quarrels and so on. I would be pleased to know as well whether somebody like Maupertuis has anything to say, and I don't remember if I've investigated that, and if so, what I found. But if you tell me, I'll be glad to learn. Thank you.
Thank you. Thomas Feeney, please keep it short.
Thanks, Brian. I just have a question about one point that you made fairly quickly, that the third law couldn't be recovered by an interactionist because the soul would inject a change into the physical world, but there wouldn't be any equal and opposite reaction on the soul. But if there is mind-body interaction, it would presumably be two-way, and signals would go from body to soul. So what's the basis for saying it would be only a sort of a one-way motion?
Good question. Okay, yeah, 2 points. One, I'm not sure that interactionists necessarily need to talk about two-way. I mean, I think, to me, soul-to-body interaction is much less mysterious than body to soul. I mean, I have no idea how bodies could affect souls. And so, if there's any kind of interactionism, maybe the answer is bodies don't affect souls. Maybe souls sense bodies, for example. So, maybe there are two arrows, but they're of totally different natures or something along those lines. If you're a Lewisian in terms of counterfactual dependence, you'll have trouble even making the distinction. So maybe that helps, or maybe hurts. Anyway, so why do I say there couldn't be an equal and opposite reaction? Well, I mean, there was a point that was made actually in the 18th century that there doesn't seem to be any sensible notion of proportionality, between mental events and physical events, and I think that roughly means that it just doesn't make any sense to imagine quantifying these things in the soul. And if it doesn't mean that, I would still say it just doesn't make any sense, because energy and momentum are mathematically described things. And if you write down the mathematics for energy and momentum conservation, there just isn't any sensible thing you could say that would ascribe energy or momentum to the soul. You can write down things that says, here's how the soul puts energy and momentum into the body. And of course, those things might be false, so they might be true, but it's easy enough to write them down. But there's just nothing sensible you can write that would count as giving energy and momentum to the soul. It's basically a category mistake or something of comparable gravity. I hope that helps.
Dan has the last question. I think we'll have to give up on the idea of a shared Q&A, so maybe just ask the question now.
Thank you very, very much. This was very interesting. I still do believe what I did right about Descartes.
Good, thank you.
Just a couple of comments. One about Leibniz and inelastic collision.
Okay.
Problem for him because every body was divided into smaller parts to infinity. His view is, in the case of the two snowballs coming together, the vis viva was just simply transmitted to the smaller parts. So it was still there. It had to be. For him, conservation principle was based on a metaphysical principle, of the equality of cause and effect, which simply could not be violated in nature, which is why I'm very interested in hearing Andrew's account of miracles. It looks like it's going to be very difficult it is very difficult for Leibniz, I think, to deal with miracles. But also putting Leibniz's view into historical context, he is in a certain sense dealing with both materialism and dualism. And what he has done, which is really quite remarkable, is figured out a way in which to have a non-interactive dualism, in which everything that goes on in the body can be explained entirely mechanically, but at the same time, and it's got to satisfy conservation laws because of this metaphysical principle. But at the same time, there are souls and there are metaphysical arguments for why it is that there have to be souls. Putting them together, the solution is pre-established harmony, which is what he took that argument to establish, which is that the only way in which you could satisfy all of these metaphysical principles is through pre-established harmony. So he's just simply willing to give up interactionism altogether, but not give up dualism.
That's a very helpful motivation to see where it all comes from. Thank you.
Okay, thank you, Brian. There is an additional comment that we will not be able to get to from Philip Sloan that looks interesting for you. But now we really do have to move on to the second talk in our panel. So our very own Andrew Chignell talking about Leibniz and miracles.
Okay, great. Thanks very much. Thanks for the invitation. Thanks for coming. Everybody at a hectic time. I should say I got the second vaccine yesterday and it is definitely affecting me. And so I did not have time to make a really nice PowerPoint, but I'm going to do it kind of old school way where I read you through a lengthy handout, which is pasted in the chat if you want to download the PDF yourself. But I'll now also share the screen and talk you through it. Can everybody see that? Okay, so a nice picture of a miracle there from the 17th century. That's Shadrach, Meshach, and Abednego getting some help from an angel, the fourth man in the furnace. But I'm going to refer to that story a couple of times, and so I thought I'd put it up there. So here's the title now, Good for Bodies, Painful for Minds. So that gives you a sense of what I'm going to try to talk about. This paper is, I have nothing like Brian's incredible sense of the science and the sweep of the history. So this is really much more of a sort of look at a few things in Leibniz that seem to lead in a certain direction. The paper is actually coming out of what was a paper comparing Leibniz and Kant on this issue. And the warm-up part about Leibniz kept getting longer and longer. So I'm trying to see if I can make something of it on its own. So we know that Leibniz is more committed than the average religious person or philosopher that matter to kind of hardcore deterministic intelligibility of the natural world. And it looks, as Dan was just suggesting, like such intelligibility would preclude any intervention from outside the system that would lead to a violation of the laws. These dual sympathies, biblical monotheism and arch rationalism, if you will, generate a powerful tension in Leibniz's philosophy of nature, because of course he wants to preserve the appearances of adherence to traditional religion. His way, I'll suggest, of marrying these two efforts, these two commitments, is coherent, or at least a partial success. So I think he can have his miracle doctrine and eat his deterministic cake too. However, the marriage comes at the cost of a certain amount of epistemic inhospitableness, at least for us and our finite minds. And so it raises questions about whether it could really be part of the best possible world. And here in the longer project, I argue that Kant also can accommodate miracles in his picture and has a surprisingly kind of Malebranchian Leibnizian picture, but that the fact that he teaches us to express and embrace a kind of ignorance about fundamental facts, even though they might still be lawful, transcendental level, that makes his picture look a bit better. At least it doesn't raise this question about epistemic inhospitableness. with respect to this topic. Okay, so we need a conception of miracles in order to go forward. Where better to look than J.L. Mackie, Hume scholar, famous atheist who thought a lot about what miracles are. Miracle is an event that occurs, quote, when the world is not left to itself. So, you know, God intrudes, when something distinct from the natural order intrudes into it. By natural order, Mackie means the order described by the natural laws or regularities, the principles that, quote, describe the ways in which the world, including, of course, human beings, works when left to itself, when not interfered with. So there's a little bit of kind of touchy language there, but the virtues of the definition are many. I think it captures a lot of what religious people mean when they talk about miracles in the empirical world. I think it's compatible with the Humean conception of miracles as roughly something like exceptions to law-like regularities. Makes sense since Mackie himself was a Humean. Fits, however, with older conceptions of miracles as events in nature that are beyond the productive power of anything in nature and can remain neutral about what the laws of that nature consist in and if and how they are violated. It's also irenic. So this might be the one place where J.L. Mackie and prominent religious apologist and philosopher Timothy McGrew agree about something. So I will call this somewhat provocatively the Mackie-McGrew miracle picture. On this picture, an empirical miracle obtains, and again, we're not talking about soteriological miracles or eschatological miracles or moral miracles. So this is miracle in the empirical world obtains when a being that is not a part of the order described by the laws of nature purposively intervenes to produce an exception to at least one of those laws. Some luminaries in the tradition of thinking about miracles, Aquinas, Hobbes, Clarke, and others, add to this a kind of psychological or informational component. So it's not just a miraculum, but a portentum, to give you some information about God or something special. Mackie and McGrew, as well as I think Leibniz and Kant, wisely keep this out and just make it a metaphysical picture. So you have to distinguish between, in German, Wunder and Bewunderung, so actual miracles and mere wonders, where, you know, the 7 wonders of the world are wonderful, but they might not actually count as miracles. A wunder is just something that interrupts the order of nature, according to the early Kant. Okay, so let's turn back to Leibniz. I think he's got at least 5 distinct concepts of miracle, which is part of why it's difficult to work on this. 2 of them are not really relevant for us because they're not about empirical miracles. So these would be miracles of the first rank, as he calls them, in a couple of places, or miracles of the highest order. These are direct, involve immediate divine action, no creaturely contribution or mediation. Creation, annihilation, and incarnation are the ones he cites. Very difficult to fit concurrence in here insofar as Leibniz is a concurrence theorist, because you want to know what to do about this no creaturely contribution part. Robney has a nice move, and Robert Adams has written a lot about this, and Des Hogan writes about it in the Leibniz context, but it's not, I mean, that's important, but we're not going to talk about concurrence here. Obviously, all of these are impressive acts, but not miracles in our triple M sense. Then the other thing to set aside is the wonder conception, which Leibniz calls miracles only by comparison. Here he's just following Aquinas, who says the angels can do something that is outside the order of corporeal nature, though they can't do anything outside the whole created order, which is essential to a miracle. So Aquinas doesn't think that they're real miracles either when the angels are buzzing around ministering to people and intervening. Actually, Leibniz is stricter than Aquinas, doesn't want to allow the angels to violate the laws of corporeal nature up here. Rather, he views biblical episodes like Peter walking on water and water turning into wine and mysterious movement of the pool at Bethesda as just in accordance with the laws of bodies. These are just angelic bodies, more rarefied and more vigorous than those we have at our command. So I guess the idea is the angels move very quickly to exchange wine for your water when you're not looking, all within the laws of nature, but not something we could do. Okay, here's for us the more interesting 3 conceptions. I think in the end, they're coextensional. Their extension is the same, but they're 3 different conceptions, and so it's worth looking at these. This is also, I think, where the tension starts to arise with respect to Leibniz's efforts to save the religious appearances. He calls this conception the philosophical conception. Aquinas calls it the miracle properly so called. And the idea here is that it's something that surpasses or exceeds the powers of all creatures. So to our know, he says, strictly speaking, philosophically speaking, God performs a miracle and does a thing that exceeds the forces that he's given to and conserves in creatures. To Comte, he says, any event that can occur only through the power of the creator, its ground not being in the nature of creatures. Now, Leibniz is careful to note that by nature in this context, you mean not just our natures or the nature of the substances we know about, but actually all limited natures. So that would include the demons and the angels and the rarefied bodies and so forth. So these are not merely comparative miracles. There's something different. Nicholas Jolly, looking at some of these texts, provides this analysis. You can call it the Jolly biconditional. Leibniz would recognize an equivalence here. X is beyond the causal powers of nature, causal powers of creatures, just in case X is an exception to a law of nature. So beyond the causal powers of all creatures. That's what gives us also an exception to the law of nature, which of course is itself just a way of describing the causal powers of creatures. Here's a fourth conception prominent in the discourse. Miracles are above the subordinate maxims of God's will. This is kind of Malebranchian in spirit. That is above the contingent laws of nature, even though they're still, quote, in conformity with the universal law of the general order. So this you knew was going to be coming. We've got the laws of nature as we try to describe them, and then there's the true or most general order of things, the essential law of the series, which describes what actually does and must happen, and any miracles as well as any other events will be a fortiori derived from it. So that's the law of the series. Some of the miracles derived from the law of the series are not just above, but positively contrary to the subordinate maxims, which we call the natures of things. Leibniz, to our know, in 1686, miracles are contrary to some subordinate maxims or laws of nature. There's Thomistic precedent here as well. Aquinas says a miracle is contra naturam when there remains in nature a disposition that is contrary to the effect that God works. As when he kept and here's Shadrach, Meshach, and Abednego, that kept the young men unharmed in the furnace, even though the power to incinerate them remained in the fire. And as when the waters of the Jordan stood still, even though gravity remained in them. Focusing here just on events in the natural world, so again, not sort of eschatological or non-empirical events. This fourth contra naturam conception of a miracle and the previous one will have the same extension. They both pick out all and only the events that are beyond the power of things in nature, and therefore contrary to the way nature normally works, and thus exceptions to the natural laws qua subordinate maxims. Okay, that's number 4. Here's the last one, fifth one. Leibniz wants to, he's a great appropriator, a kind of eclectic synthesizer. So he also wants to appropriate this picture according to which God extraordinarily and miraculously concurs with the powers of creatures in some cases. So this is not a divine act against nature. Rather, God concurs, but in an extraordinary way with something in the creatures to produce an event that is an exception to the laws set out by the natures of those very creatures. So it's contrary to the natural laws qua subordinate maxims, and in that sense might have the same extension as the previous conception. But Leibniz wants to say it's not contrary to the natures of things. And here I think he's moving away from the scholastic picture. Aquinas, as well as Molina and Suarez, will say that when the 3 captive Israelites enter the Babylonian furnace, the dispositions of fire, human hair, skin, and flesh do not receive God's ordinary concurrence. There's a sense in which God blocks what would normally happen. It's because such concurrence is a necessary condition of the usual combustive effects that the 3 young men are not harmed. Leibniz views this account as unfitting. It robs creatures of a certain kind of power, God blocking them unfittingly in contrast, in conflict with God's own creation. So Leibniz is going to say God never withholds concurrence altogether. Rather, God actively confers with the powers of creatures, maybe slightly different powers, but in an extraordinary way. And he says this difference must also be internal to the creature somehow. This is a kind of puzzle, not merely an extrinsic denomination located wholly in God. So this seems to rule out any suggestion according to which God allows the exercise of the ordinary powers, but then blocks their effects. A promising suggestion here, maybe extraordinary concurrence involves God taking one of the pre-existing powers of the creature, and instead of blocking it or not concurring with it, God strengthens this other one or increases it somehow. We might wonder how this counts as being beyond, or so, I mean, for example, perhaps the fire stays the same as it was, but the ordinary anti-inflammatory powers of Abednego's skin are strengthened to the point where it can resist the Babylonian inferno. This is a slight variation on the previous picture, on the Suarez Molina picture, but it succeeds in making the account look less ad hoc. Extraordinary concurrence builds on, rather than being a mere extrinsic denomination, builds on the natural powers that are already in the creatures, but also goes beyond them. A difficulty still remains, however. We might wonder how this beyond or increase in the substance's ordinary powers itself has an explanation in the natures of the creatures. So again, the difference must be internal to the creature somehow. And you wonder if that extra oomph or push that God gives to some of the powers is internal enough, especially given the sort of rationalist impulse. If it isn't, then the suggestion threatens to run afoul of Leibniz's principle that everything in creatures, every perception and every change must be explained by their natures, and his commitment to the idea that the difference between an ordinary case and an extraordinary miraculous one cannot be merely an extrinsic denomination located in God. So here I think the tension is real, and I'll return to it with sort of three strategies now in this next section. Given what we've seen so far, it looks like the main obstacles to empirical miracles arise from Leibniz's longstanding opposition to occasionalism and his commitment to the perfect principle of perfection. Opposition to occasionalism says there has to be a real ground in the finite things. That also helps him resist Spinoza, obviously, and maintain the distinction between God and the rest of us. So there has to be real active powers in the finite things. And moreover, something in the finite things, substantially, maybe in their substantial forms, that grounds the presence of every state that they exemplify. So how do miracles fit in here where it looks like God is super adding something? The other obstacle arises from Leibniz's commitment to the principle of perfection and therefore to principle of sufficient reason and rationalism and so forth. How can the intelligible natural laws that we seek in scientific inquiry admit of exception? For wouldn't the supremely rational, competent, and benevolent engineer make the elegant laws that we approximately grasp also be the laws that really govern the series, especially given the fact that Leibniz explicitly ties perfection and happiness of minds to their ability to understand the phenomena. Now, there are some passages, I mean, Leibniz is a little bit all over the place on this issue, so it's hard. Obviously, there are problems about when certain texts were written and how the view develops, which I'm not attending to here as much as I should. But it looks like back in the discourse, he's willing to say things that sound like he's ruling out miracles. So here's this passage. When we include in our nature everything that it expresses, nothing is supernatural to it, for our nature extends everywhere, since an effect always expresses its cause and God is the cause of substances. I want to suggest that what appears to be a denial of miracles is not actually correct. Leibniz goes on to say here that it would be better to use the term essence or idea to refer to the collection of all of a substantive properties and reserve nature in the strict sense for that collection of properties that a substance, quote, expresses more perfectly and in which its power consists. Later, Leibniz says, he proposes to think of the nature of a substance as a function of its active powers, powers that are themselves finite limited, of course, whereas its overall essence, quote, contains many things that surpass the powers of our nature, surpass our nature, and even surpass the powers of all limited nature. Much later in the Theodicy, the distinguishing mark of miracles, taken in the strictest of senses, is that they cannot be explained by the natures of created things. Here it looks like maybe nature is being used in the strict sense as opposed to essence. Okay, but then in what sense are properties in our nature within our power in a way that the features of our broader essences are not? So two approaches to this. I'll endorse the second one, or at least plump for it a little bit. The first one, however, we can call wholly passive. This approach says that the properties in our nature are, quote, within our power because at some level, which need not be conscious, we want to have them. Leibniz says that the primary force or active power of a substance is directed to the series of states in its nature via conscious or unconscious appetition. That's familiar. This would allow him to say that the substance is wholly passive with respect to the remaining extra natural properties of the broader essence. So you have some appetition, even an unconscious one, for the states in your nature, and you're wholly passive with respect to the properties in the essence. This would help explain why Leibniz inserts the word or idea after essence in the second edition Discourses discussion of this issue. It's merely part of your idea, not part of your nature. It also coheres with his general doctrine that miracles are willed directly and by God alone. But again, wholly passive threatens to eliminate the positive ground in creatures for the contents of the broader essence. The ground now lies completely in God's idea. So what looks like a benefit is also a cost. It's difficult to square with the anti-occasionalist drive in a lot of these texts, according to which Leibniz wants to say all of our states, not just the states of a narrowly circumscribed nature, are the partial result, anyway, of our primary active force. For example, I believe that there is no natural truth in things whose ground ought to be sought directly from divine action or will, but that God has always endowed things themselves with something from which all of their predicates are to be explained. So, a friend of wholly passive could emphasize that Leibniz says here that there's no natural truth in things whose ground is solely in God's will, and then argue that this leaves room for supernatural truths about the essence that are so grounded. It's not clear what they could say, however, about these other passages. Here's one from the Theodicy. In my system, every simple substance, that is, every true substance, must be the true and immediate cause of all of its actions and inward passions. Strictly speaking, it has none other than those which it produces. Back to the discourse, the soul must actually be affected in a certain way when it thinks of something and must already have in itself not only the passive power of being able to be affected in this way, but also an active power, a power by virtue of which there have always been in its nature marks of the future production of this thought and dispositions to produce it in its proper time. If we interpret thought here as referring to all of our psychological states, including those that are in the broader essence, but not in the nature strictly speaking, then this passage makes it very difficult to see how any state of substance could be wholly a result of the active powers of some other substance, namely God. Okay, a better approach, I submit, is one that takes seriously the thesis that all the states of a substance are somehow grounded in the active powers, but then exploits the fact that such powers seem to come in degrees. So we can call this the degrees of power proposal. A few pages before the passage I just quoted from Specimen Dynamicum, Leibniz says that substances have both active power, virtus, and passive power, and that in finite creature, these powers are found in different degrees. So passive and active, different degrees. Likewise, in the much later monadology, Leibniz characterizes active force as a perfection, passive force as an imperfection, and indicates that both of these come in degrees. So the degrees of power proposal then simply says that miracles that surpass the power of nature, insofar as finite substances, miracles surpass the power of nature insofar as the finite substances involved in them have just a very limited degree of active power with respect to those events. So it's not an entirely extrinsic denomination. It's much more about passivity than it is about activity, but there's a very limited degree of active power, even with respect to your time in the furnace in Babylon. Indeed, perhaps this is true of all the states that are only in the essence. They are the result of a very limited degree of creaturely active power, appetition, so forth, a degree much lower than the degree of passivity that the same states have with respect to God. The advantage here is that we can maintain that there's no state of a substance that's not to some degree a function of its active powers, while also making use of the nature versus essence distinction to account for miracles. In other words, it allows us to accommodate what I was calling the anti-occasionalist obstacle to the miracle doctrine, where the precise line demarcating the states of our nature that are within our power from the states that are only in the broader essence and thus outside our power, though not entirely, would be hard to draw, but it would need to fall comfortably beyond the point where the degree of active power directed toward the relevant states is exceeded by the degree of passive power vis-a-vis God's activity. Lingering problem for this picture as well as the previous one, however, has to do with that other obstacle, the principle of perfection. And here I just don't have much to say by way of helping Leibniz. For Leibniz, a change in a substance that is either wholly or largely a result of its passive powers is ipso facto a change from the more perfect to the less perfect. But if a miracle involves that kind of change, then the occurrence of a miracle will decrease a finite substance's overall perfection by demonstrating its weakness, some pain. Now, if you ask Shadrach what he thinks, he might be fairly happy about the goodness for his body that resulted from this miracle, but the goodness of the body came with some badness for the mind, indeed some pain for the mind. So here in the discourse, Leibniz says, thus, to speak more clearly, I say that God's miracles and extraordinary concourse have the peculiarity that they cannot be foreseen by the reasoning of any created mind, no matter how enlightened. So it's not like we just can't figure it out now. We could never figure it out because the distinct comprehension of that general order surpasses all of them. On the other hand, everything we call natural depends on the less general subordinate maxims that creatures can understand. So we saw this subordinate maxim doctrine before. However, the claim that no finite mind, no matter how enlightened, could foresee a miracle by reasoning indicates that no inference based on laws or antecedent conditions could ever lead to the conclusion that the miracle will occur. This feature, their unintelligibility to finite minds, makes miracles a problem for Leibniz, I think, even more than the metaphysical problem. And it's a consequence of the ontological facts of the case. The divine ground of the miraculous event, the law of the series that God wills, is too complex for us to understand. And this is hard to square with the principle of perfection. Here he says in the specimen of discoveries that the happiness of finite minds is a function of how well they understand the phenomena. It's clear that minds are the most important part of the universe. Everything was established for their sake. So in choosing the order of things, the greatest account was taken of them, all things being arranged in such a way that they appear the more beautiful, the more they are understood. So it must be held certain that God has taken the greatest account of justice, and just as he sought the perfection of things, so he sought the happiness of minds. But if our happiness as intelligent beings consists in the perception of the beautiful order of the universe, then oddly enough, the perceived occurrence of a miracle will leave us frustrated and discontent at some level. There will be, again, in the language of the discourse, more weakness and pain in the world as a result of the miracles, even if on balance they contribute to the good of the whole and the good of our bodies in the furnace. This is what I think seems theologically unattractive and may explain why Leibniz often appears to downplay even the metaphysical possibility of empirical miracles. There's a related concern here about how the miracles doctrine on either of these proposals would cohere with Leibniz's overall claim that the world is also arranged in the simplest possible way by the maximally great engineer. Robert Adams raises this problem with reference to the passage in Discourse 16, according to which miracles make the general order so complex that it's incomprehensible to creaturely minds. That passage I just read. And Adams says, how that is consistent with the preeminent simplicity of the actual general order, Leibniz does not explain, as far as I'm aware. So a kind of additional concern there about whether this is coherent with simplicity. In light of these sorts of concerns, so here's a kind of third big option. First was wholly passive. Second was degrees of power. Now third is nature and essence collapsed. So in light of these sorts of concerns, some commentators opt to collapse the discourse distinction between nature and essences altogether and say that Leibniz didn't mean it or abandoned it. Don Rutherford, for instance, claims that for Leibniz, quote, any substance is endowed with an intrinsic force or power sufficient to determine all of its own states or modifications. I mean, the all emphasis was mine, but it is there. There's no talk of degrees of active and passive power here. No suggestion that these degrees could be used to demarcate a substance's strictly speaking nature from its broader essence. In a co-written piece with Jan Kover, Rutherford says, Leibniz's naturalism is specifically intended to rule out the possibility that physical or psychological phenomena are in any way miraculous. That is, that they occur in a way that could be explained only by appeal to direct intervention by God, or to, now look, like only by appeal to direct intervention by God, that sort of neglects the degrees of power picture where the tiny bit of active power in us that is part of the explanation. Or to occult powers that lie beyond the reach of reason. Instead, all natural phenomena can be explained in terms of the action of powers inherent in the natures of created substances. So fairly strong view. If by natural phenomena here, they mean phenomena that can be subsumed under the laws of nature, then this is correct, but trivial. The first sentence here, however, all physical and psychological phenomena indicate that what they mean is all the phenomena whatsoever that could be produced, even those involving special intervention. And so claim that all such states are the results of the active powers of nature with which God simply concurs, if at all, in the ordinary way. That in turn indicates that by natural phenomena, these authors mean all of the phenomena that do or can occur in the natural world. This is a non-trivial claim and just seems to rule out empirical miracles. In support of their model, Rutherford and Kover could cite the passages up above that looked fairly dismissive of the nature versus essence distinction as being able to support this kind of a model. Or for instance, the following quotation, in every substance, there is nothing other than the nature or primitive force from which follows the series of its internal operations. This series, that is all of its past and future states, can be recognized from any state of the substance, i.e. from its nature. Passages like this, again, suggest that all phenomena in nature, all the states of a substance, even the states when you're in the Babylonian inferno, are completely determined by the active forces which constitute natures. There's no room on this view for an appeal to some sort of broader essence. Okay, so that's a strong view, collapse the distinction. I think there are attractions to it. There are some textual materials that support it. I think, however, the case is not compelling. For one thing, the degrees of power proposal may be able to handle, as I just interpolated the text just cited, by maintaining that the entire series of states does get some input from the primary force of a finite substance, provided we take into account even the smallest degree of force. So that solution is going to constantly insist that you just need some small degree of active power with which God is then extraordinarily concurring and sort of amplifying its usual effect. Moreover, we've seen there are numerous other texts in which Leibniz links the natural powers of creatures to the laws of nature and then allows that other sources of change in those creatures are possible. Such a change would be accounted for by, of course, the general law of the series, but not by the subordinate maxims or the laws of nature. In other words, it would be a miracle. We've seen that this is true not only in the relatively early discourse, but also in the letters to Arnaud. There's also some good passages in the new essays, which I didn't put in here. And this one from the Theodicy. Thus, it is made clear that God can exempt creatures from the laws he has prescribed for them and produce in them that which their nature does not bear by performing a miracle. So a difficult textual situation, exemplifying this tension, I think, between Leibniz's effort to save the phenomena of the religious traditions that he's a part of while also sticking with his rationalist determinism. So here is where I am at the moment on this kind of upshot, or at least provisional upshot. The goal was to see whether Leibniz has a way to incorporate empirical miracles into his overall picture of nature, and thus eliminate the tension between biblical monotheism and his extreme form of rationalism. We can summarize the puzzle in the form of a dilemma. So it's a two-horned dilemma. If empirical miracles construed in the Mackey-McGrew way are included in creatures' essences, but not in their natures, then we're left with no positive ground of the relevant states in the substances themselves. Any miracles become mere extrinsic denominations, which seems contrary to the doctrine that all changes in substances have some ground in the active power of those substances. On the other hand, if essences are collapsed into natures in the Cover-Rutherford way by construing both as fully grounded in the active powers with which God simply ordinarily concurs, then Leibniz's system is unable to accommodate the possibility of empirical miracles, and the many texts in which he continues to speak of them must be regarded as confused or disingenuous, an unattractive result. I think the wholly passive proposal basically just embraces horn A, but I meant to articulate degrees of power as offering a way between A and B. So grasping neither horn, but somehow going through the middle. Degrees of power says that natures and essences can be demarcated by considering the degree of active power involved in a given change of state. And if a finite substance's degree of active power with respect to some changes less than its degree of passive power vis-a-vis God, then the change may count as an empirical miracle. So it's a necessary condition. There are changes in slumbering monads here that are all about passive power and so forth, so you have to be careful, but at least it's a necessary condition. And then if God actually adds the oomph, then you've got a real miracle. In other words, the state is outside the creature's nature, strictly speaking, in the terms of the discourse, and thus not within its power exactly, even though it is grounded in a very limited degree of creaturely active power. So the degrees of power proposal also explains how Leibniz can regard empirical miracles then as surpassing the power of natures, going beyond, in Jolly's terms, going beyond the power of creatures, and as exceptions to the law qua subordinate maxims, and yet as the result of extraordinary concurrence with some small degree of active power in creatures. Finally, it can leave the three concepts of empirical miracle that we considered as extensionally equivalent. Degrees of power does not, however, resolve the epistemological puzzle, or at least I can't yet see how, regarding how the decrease in intelligibility of the world and the happiness of rational creatures is consistent with its overall perfection. Perhaps the best thing to say on that issue, as usual, it is that it's least conceivable that all the other worlds God might have created would have been even less perfect overall somehow. But, and this is the rub, it would surely be preferable from a religious point of view if Leibniz could accommodate the thought that, you know, me being thrown in the furnace and not burning up adds to the world's perfection, instead of just adding intellectual pain and making things less perfect. So even if Leibniz can include Mackey and McGrew empirical miracles into his philosophy of nature, and I think with this degrees of power model, he perhaps can, at least some of the tension between his rationalism and his religion remains. And here the cover of the best Beastie Boys album, An Exciting Evening at Home with Shadrach, Meshach, and Abednego. Thank you.
Thank you, Andrew. Okay, questions, please drop a line in the chat or raise your hand. Oh, someone has it. Who has a hand up? Let me see. Oh, yes.
Can you hear me, Claudia?
Yes.
Yeah. Yeah, thanks, Andrew. I guess, don't you have to take account of the very important rhetorical function of all of these distinctions? Leibniz is making here. I mean, he's trying to say something. He knows that there are plenty of dim-witted religious fundamentalists around who are more impressed with the notion of a violation of a law of nature than with a law of nature, even though, of course, the law of nature is itself completely the result of God's action. And so a lot of this is surely just a lot of rhetoric, presumably to stay out of trouble and have something to say to these people while, maintaining his naturalist, rationalist view in the background. So it's less about trying to square his own rationalism with what he finds in the Bible, and more about trying to say something to people who he knows there are plenty of them in Germany at the time, who are very impressed by this and will make an objection on these grounds. And if that's the case, so you have to be able to say something to the miracle mongers, basically, and that's what he's trying to do with a lot of this. Isn't that the best way to read what's going on here?
I mean, that's effectively the Rutherford Covert response. And so it would be an embrace of the second horn of the dilemma. I don't know, I feel like if there's a model that is compatible with his picture and allows him to save the appearances a little bit better than that does, that would be preferable. I mean, I'm admitting that there's still a problem about the perfection of things, but it feels like just a kind of Straussian reading where it's like, Leibniz really didn't care about this, but he was just throwing a bone to the pietists or the censors or the theological authorities is, I mean, maybe that's the historical fact of the matter,
well,
but it seems like we shouldn't go for that right away.
I think he did care about it deeply, but it's just, the point is just Spinoza's point that the dim-witted people are more impressed with a violation of a law of nature as an act of God rather than a law of nature as an act of God. And so, it's not that it's irreligious on his part to be a rationalist. He's totally a theist, right? But he wants to say something to these people or be able to say something to them. So, surely he's just steeped in this thought of Spinoza that, the sanctuary of ignorance, the notion that a violation of laws is more impressive than laws to a lot of people. And he just totally agrees with Spinoza about this, that's rubbish.
But what do you make of all the texts where he says things pretty explicitly about the laws of nature just being this? I mean, it's Malebranche, right? They're just the subordinate maxims. There's a deeper law of the series that doesn't get violated, but the laws of nature occasionally do. Is that
he wants to draw a distinction there so he can offer these people a bone. I do agree with that. And I mean, there is this distinction that Bob made, the two Bobs, Bob Slay and Bob Adams, between the super essentialism and the super intrinsicalism in the context of the complete concept theory and so on. And the point was, maybe Bob will correct me if I get this wrong, that they wanted to say that God could have made something different happen, but wouldn't have in a certain sense. So he doesn't want to be an essentialist. He wants to be a super intrinsicalist. So he can draw that distinction, but it's also very important that he wouldn't have, right? And that's where the rationalism comes in. So.
Yeah, but the picture here would be God having set all of this up beforehand. So the miracles that count as exceptions to the subordinate maxims are all set up as part of the law of the series and the pre-established harmony. So it's not, I agree. I felt to me like that debate is more about could God change things along the way or annihilate a substance halfway through or something like that. So I think that isn't something that he would be able to endorse. But I mean, maybe you're right in the end. I just wanted to see if I could make a run for a model that allows him to keep most of the rationalism, but allow us to take the religious texts more seriously. But I appreciate the question.
Thank you. Dan?
Thank you very much, Andrew. I mean, that's really a very helpful sort of survey of all of the different and not altogether consistent things that Leibniz has said about this issue. In a way, I kind of tend to agree with a lot of what Des said. I'm not sure that Leibniz followed Spinoza on the rejection of miracles altogether. But to sort of connect this with the previous paper, the argument that we were discussing there that we were beginning with in Leibniz was basically that interaction is impossible because it would require a violation of the laws of nature. And that's basically what it is. If Descartes thought that he could do, well, Leibniz's argument is Descartes thought that he could do interaction without violating the laws of nature, but that's because he misunderstood what the laws of nature were. If he understood correctly what the laws of nature were, then he would have seen that it would require a violation of the laws of nature, and he would have come up with pre-established harmony. Now, I think he was wrong about interpreting Descartes. I think Descartes did not believe that the conservation law was inviolable for complicated metaphysics. Well, not very complicated.
I mean, if there were no freedom, then that's how it would run. So it's more like the conditionality thesis.
Well, no, it's just simply his understanding of the laws of nature were grounded in God's action on the world. Acts on the world in such a way that when he's acting on the world, conservation principle is conserved, but there's a second agent acting on the world, and that's human minds or human souls. And therefore, there can be violations, but they're not by God. So it's okay.
Right. No, that's what I thought Brian meant by condition. I thought that's what Brian meant by conditionality, that if freedom wasn't involved, then yeah, okay.
Yeah. But on the other hand, it's quite clear that Leibniz really thinks violations are impossible, and that's why it is, I think, that he was not at all happy with Malebranche's version of a hierarchy of laws, where higher laws can cause violations in the lower laws, all the way up to the ultimate laws of grace. He wasn't happy with that at all. That did not fit his conception of the ways in which the laws of nature work. They have to be inviolable. The basic principle of the equality of cause and effect cannot be violated.
But so I'm surprised to hear that. I mean, both you and Des are far better Leibniz scholars than I could ever be, but I'm surprised to hear that there's a willingness to dismiss so many texts.
Well, I'm not sure what to do with it, to be perfectly honest.
Yeah.
So I sort of tend in that direction. But the thing is, if he would allow, and this is why it is that I find it very difficult to see how he could allow miracles, because one way or another, the miracles are going to involve violations of the laws of nature. And if he is willing to allow violations of the laws of nature, then why not just simply throw in the towel and allow for direct interactionism, which he is not willing to do?
Maybe when it's God involved, somehow he's willing to allow for interaction, where with the mind, the finite mind, he wasn't.
Maybe, obviously God is, but
so maybe the way I can put my thesis is, if you're willing to take these texts about the violations of the subordinate maxims seriously, then here is this model, the degrees of power model, that does the best job of saving a lot of texts and saving most of the theory. But I grant that a lot of people just don't even want to take a lot of those texts seriously.
Yeah, I think another way of thinking of it is Leibniz was struggling. Now, on the one hand, I think his basic instincts were toward, in a certain way, Spinoza's view, that the laws of nature are an expression of God's power, and it is not conceivable, really. Violations are not conceivable. On the other hand, it certainly was problematic to the extent to which he was a serious Lutheran, to simply say that miracles are not possible. And he was looking for various ways of resolving the tension between the two of them. And at every moment, it is perfectly plausible to say, and this is a place in which I might disagree with Des, it's perfectly plausible to say, well, he believed it at the moment, but in the end, I think the tension may remain.
Just feels like Leibniz is the kind of philosopher that you would want to be a bit more honest than that and say, not all of these things that he seems to say quite straightforwardly, but I'm really having trouble here. I'm struggling to see how this fits. Like, this is a remaining problem, but you don't get.
Well, this is, I think, a manifestation of a tension that he, this may be a manifestation of a tension that he feels between two different views, both of which, are for him attractive. But it's not this in part is my reading of the way in which Leibniz thinks. I mean, he is constantly, and this is, I think, a very admirable thing. He is constantly thinking, rethinking, trying to, he appreciates conflicts and tensions and is looking for ways of resolving them. And some of them he never manages to completely resolve. And which is why I think in some cases you do have back and forth on issues, as in the case of miracles.
Right.
But other people will read him differently.
Interesting. Thanks.
Thank you both for that exchange. Alberto Luis Lopez.
Hi, Andrew. Well, I was, thanks for your talk. And my question and my comment is related to the last words of Dan Garber. Because I was thinking, sometimes we can track two moments in philosophers, to some extent, no? On one side is from a philosophical point of view, and from another side is a personal religious belief. And sometimes they try to square both moments or both positions. So on one thing is what God can do, and try to make compatible God's attributes with the human conception of God. And another thing is what philosophers, and some philosophers believe about miracles from their personal religious beliefs. And I say it because this, for instance, in George Berkeley's case, we can read in Alciphron Berkeley's position about miracles. And he says some words in Alciphron, or sometimes there are some mentions in Principles and Dialogues. But if we read one specific text, is a letter to Sir John James, is 1741, Berkeley rejects completely the possibility of miracles by saying that this was a moment, just occurs miracles in the time of the primitive church, and that's all. And now this is just a superstition from a Catholic perspective. So we can have like two readings in Berkeley. If you consider Alciphron, he said, well, of course, miracles are possible because God is a powerful entity and so on. But if we read this particularly text, a letter to St. John James, he said something different. And I think it's, to some extent, is his personal religious belief. So my question is, in Leibniz, we can find something similar or not? I don't know if you have something to say about it.
I mean, I didn't find any texts other than the ones I gave you that would suggest that he's got some sort of deeper commitment that he's not always honest about. I mean, it just looks to me like sometimes there are texts where he says P and sometimes not P, and the effort is to put them together without it looking like a straight up contradiction. And of course, these are texts that are written over 30, 40 years, and so that's also a problem. But even within the same text, there are these tensions. And I'm actually, it's interesting for me to hear that it seems like a lot of Leibniz commentators are willing to just sort of give up on this one and say Leibniz didn't sort it out very well for himself, or else he was being disingenuous, which might be even worse. Whereas I would think that, charitable interpretation always tries to put it all together first and go to those sorts of positions as a fallback. Maybe the thought is just you're never going to be able to put it together. But I'm curious to see the very pessimistic sort of picture. I don't think that Leibniz is just like Berkeley there, though. I think he kind of always thought he could have it all.
Okay. Yeah, thank you. Just curious.
Thank you. Yeah.
Thank you. Philip Sloan?
Yes, my question also bears a bit on Brian Pitt's paper, the last one. And it's the interesting point, no one has exactly raised this question, is the distinction we see in Leibniz, and I think it gets particularly developed by Wolff, and then also I've been looking at it in people like Emily du Châtelet, is the distinction between substance and matter. And does that have some bearing on these questions that we've raised? Because once that distinction is collapsed, which it is in the 18th century, then we can get both a certain kind of reading of the body-mind problem, which tends either to vitalism or materialism, but also in this question of miracles and so forth. Could Leibniz be making distinctions that really cut along that line, that there's certain, within a material order, we could have some kind of what is an apparent complete determinism, but at a substantial order, things could actually have a certain kind of freedom that is going to allow that. Now, I don't know any place, and maybe some of the Leibniz scholars could clarify if he really does make that as clear as I've seen it being made, by some of the subsequent readers. And I'm thinking again back through du Châtelet, who's making that distinction very important in her discussion. But anyway, I wonder if that would have some bearing on this question of, and that is Leibniz's distinction between what we might call material or sensible substance or apparent, and also then a substance itself, which they aren't the same things. Once those are collapsed, then we have a lot of other kinds of problems that emerge.
Yeah, interesting. So that might correlate with the law, the general order, or the law of the series, and the subordinate maxims, which might govern matter. I don't think he wants to say there's any genuine, free will of the robust sort at the general bottom level, but it might accommodate other sorts of things like miracles. I don't know if Brian has something to add here.
Yeah. I don't actually. Thank you.
All right. Well, on that note, I think this concludes our panel. We're at the end of our time. Please thank our speakers.
Thanks, everybody.
I'm unmuted so I can applaud. And next week we will have the last session of this spring run of the Bucharest Princeton seminar. So Juana Mate and Fabrizio Baldassari will be talking to us about plans in the early modern period. Okay, thank you. Goodbye.
Goodbye.